Okay. Let's. Oh, that's. Okay. Publish. Okay. Discord can go. Password can go. Okay. Let's continue. I don't know. I probably didn't show anything sensitive, but I just unlisted in the thingy because I was on like my password manager. So yeah. Draw stuff. Let's draw something. Make command buffer equals self allocate command primary command buffer. Usage runtime submit results. Okay. Box on error. Okay. Command buffer. This needs to be mutable as well. Command buffer. Begin render pass. You must call this or begin rendering before. Wait, what is begin? Begins a render pass without a render pass object or frame buffer. Requires the dynamic rendering device feature. I don't think I want to do that. Okay, so we need a so we need a render pass. Wait, it's like render pass equals volcano single pass render pass. Okay, I had an entire like rendering module. I'm probably just gonna remake that in this one. Render.rs. Actually, I'll create. I don't know. Render.rs. Yeah, I'll make a rendering structure, and then. Why isn't there any code actions? What is going on? Put render. Perfect. So render pass. Render. Yeah, all of this looks correct. You know what I could do? I could have like a because like in here we have a command buffer for like our render commands alongside like our kind of like renderer state, but I could pull this into a separate structure and have So what I could have is like a draw call or something that has those, and also takes in like static information ahead of time. So you have like a draw call and you pass in the textures or like the descriptor sets, Yeah, you pass in the descriptor sets you need to, and find descriptor set. So you pass in the graphics pipe. You pass in the graphics pipeline and the descriptor set. You pass in all the resources that you need to start rendering, and then you draw a bunch of things. Where's identity matrix used? Oh. Oh, I see. What? Wait, why am I doing that? Why am I doing that? Why am I allocating a completely new descriptor set? Do I need to do that? Well, I want to see standard descriptor set allocator and city map 1064 entry fix pools threadable pool. What's entry? Oh, entry is just right here. Descriptor pool. I don't know. But either way, that's not good. I don't know. Our renderer in sugarcane is going to just contain this. Draw calls are going to contain this. And then there's going to be some sort of resource structure that will contain all of these. So let's create that. First of all, we need... That looks okay. Wait. I need to search up like Vulkan image format. Vulkan hardware database. Because it's either like BGR or RGB. That's like filter. Huh? Oh, it's processing. Oh. Optimal time format. I think it's this. I was doing in sugarcane. I was doing RGB. I don't think that's right. Yeah. Non-sRGB. Only BGR A 8 is sRGB. sRGB is supported. Well, do we deal with this later? I feel like we might deal with this later. I don't know. Wait, do we have... We need to store the image format, I think. No. The renderer has that. Format. And then... graphics pipeline. Arc. Graphics pipeline, and then render pass, arc, render pass. So what do we need for render pass? Let render pass equals no. Okay, no single pass render pass. Hello. could just do that. I don't know how to check for like depth support. We'll deal with that later. But for now, this should be the same, except that we should also pass in image format. We need a format for the color images. Color format. And we need a device. So device. And yeah, graphics pipeline. Okay. Do we need a graphics pipeline? Oh, we need a we need a shader. Right. I forgot about all this. Let's... render commands. Oh yeah. I create that, and then I store it, and then I like fill it up, send it, and then recreate it. That's a weird way to do it. I'm gonna encapsulate that in a draw call. Vertex shader, VS. Yeah. Hold on. There's like a crate, Rust GPU. There's like a crate that I saw called Rust GPU, and a significant portion of the core library also compiles. Do I want to use this? It would be really cool if I could make my shaders in Rust. Like what I'm looking at is Rust GPU, which is like a crate that allows you to write Spur 5 shaders in Rust, and I guess use them in Vulkan, which is extremely cool. It's extremely cool. But I don't think I want to use that just because it's not, like, is this? No, it's not. Okay, never mind. I thought this was my terminal shader, but it's not. Honestly, I think a lot of this will just be copying from my old, like, renderer into the new one. Mod default vertex. Well, these are going to be defaults. Default fragment shader. Do we have volcano shaders? We do not. So we have a common vertex. Oh! Do I do glam? I don't... Yeah. Wait. Cargo at. Car don't go cargo beep beep. Speedy. What's that for? Mint. Okay. This seems like it should work. I mean, we gotta wait for everything to index properly. But we have a render pass, and we need a graphics pipeline. So we'll just, while waiting for that, let's do this. That seems like a really good, that's a really good constructor. Oh, and that does use glam. So, oh, apparently it's, okay. This is not good. Drop frame, well, there's no drop frames. So it's not like, oh, is OBS lagging? I think OBS is lagging. Okay. Does this is OBS is not being OBS is just not Oh, are we good? I think we're good. Are we good? Please. I'm scrolling. I seem to have a lot of latency because I haven't... Okay, we're good. We're good. Do we just copy all of this? Because, like, it's gonna be pretty similar. Okay. Subpass doesn't exist. This looks okay. Subpass. Pipeline shader stage create info. Default. Oh, hold on a second. Vertex shader is no main, fragment shader is no main. What we're gonna do, instead of loading here, we're going to... Okay. Vertex shader, arc shader module. Go into option of arc shader module. And what that will do, so we can pass in the shader module if we want, or we can just pass in none and have it load the default shaders. Amazing. Vertex shader, fragment shader. Oh, wait, hold on. Fragment shader, unwrap or else. You know what? Match fragment shader. And then, so we'll do this. This is interesting code, but it should work. Match vertex shader. Okay. So we have vertex shader and fragment shader. We have it, so we're loading it. common vertex per vertex definition. Do these need traits? Oh, why are they? Hold on a second. Renderer. And we're going to just create the renderer inline for now. Actually, no. Renderer, new. Actually, to do for now, because we don't know what other parameters we might need. Pipeline layout, let's import everything we need. Let's import everything we need. Viewport state, viewport rasterization state, call mode back, color blend state, depth stencil state, depth state, dynamic state. Whole bunch of states. Use of undeclared type. Okay, we're good. Error. Format. Ooh, we need all of these. Need these. And glam types. So 4. Select 2. And nice. So now we're on the next stage of error. We're on like type errors, vertex, definition. Why isn't this working? Oh, right. Dot into. Does that work? Yes. And now we just have to return the right thing. I'm gonna change. Oh. Render class. I'm eventually probably gonna switch to a logging framework. But printing for now is fine. Graphics pipeline, render pass, image format. Image format. Wait. Color format. Like that? Please? Yes! No. Device. Oh, we've moved it. So now we're on lifetime stuff. We're on move semantics now. Okay. I don't know if I'll need the device later, but we'll just shove it right into the graphics device, or the graphics pipeline. Renderer, new, none, device.clone, and image format, yes. And device, graphics device, that's what I called it. Command buffer dot okay. Actually, hold on. Let's look over the graphics pipeline and see what we've actually created. Rasterization, backface culling. Like, this all looks okay. This all looks fine. Vertex input state to see. Stay in the graphics pipeline describing how the vertex input state should behave. The state in a graphics pipeline describing how. Okay. Pipeline descriptor set layout create info. That looks good. command buffer. Now we can begin a render pass with begin info. Frame buffer. We need a frame buffer. Frame buffer new. Self. You know, we could just like do that. Because why not? Self renderer. So we need the renderer's render pass. Does this need like a full-on arc? It does. Create info, frame buffer, create info, and I think we could wait. Hold on. Okay, apparently not. Apparently we can't. Like some things Okay. The attachment images that are to be used in the frame buffer. Attachments are specified in the same order as they are defined in the render pass. And must be exactly as many. So that means vec of our swap chain acquired image. Let swap chain image swap chain volcano swap chain acquire next image self swap chain clone run that index something in the swap chain image. Is suboptimal. So I forget how I did it. You know what? We're gonna look back again. New, because we had a swap chain. There's things that you have to do to like recreate the swap chain, and it's like suboptimal. If is suboptimal. So this is where we actually. Okay, so recreate the swap chain. Self surface. Oh! So if it's suboptimal, that means that. Okay. Oh, this is just propagated. Okay. So if it's suboptimal, then we recreate the swap chain and the depth buffer. Okay. Okay. Nice. Do we just current image? Why are we doing this? Why are we doing this? We don't need to be doing this. Switching images, self-depth. Okay. Ooh. I see. So we acquire an index. It's all coming back to me. We require an index to the image in the swap chain, but it's fenced, I assume. So we need to wait for it to be... No, because the swap chain, it's like... It's... Oh! I see. So we acquire an index, and then we can use that index and we index into our swap chain images, and we can do that while we're still acquiring it. We don't have to wait. We don't have to wait to acquire it immediately, which is why we don't get an arc of an image. We just get an index. And then the acquire feature, we block on this. We block on this once we need to start presenting. Acquire feature take or finish rendering called before begin. That's what that does. That's why it's an option. So the acquire feature is some when we're in the middle of rendering, and then once we've finished, we don't have to acquire anything, so we set it to none. That's an interesting way of doing that. We could just, if let else return early, we could just have a return guard on this. That doesn't seem awful. If window resized or create, okay. Window resized. That's okay. So we're going to need to handle window resizing. Swap chains, the swap chain's dealt with by the state, not by the renderer, because it doesn't have to do with rendering. I mean, it kind of does, but putting stuff on the window is done by the swap chain, using the GPU to do all the actual like triangle rendering stuff is done by the renderer. Like the renderer, like you can have a different renderer that takes in the same swap chain images and does software rendering. That's fine. That seems okay. So if we have a suboptimal swap chain, recreate swap chain is true. Let's do that. There's a few ways we can go about like recreating the swap chain, and I think that's kind of a cool thing that Vulkan does. Like, you could just recreate on the next frame. You can do an early return. There might be like a visual artifact when you resize the window or have a suboptimal like swap chain. It's usable though. If let some event equals self, I can't not do this. Can there only be one GLFW? A token from which to call. This might make performance motions harder than the truth, but safety is enforced statically. Might need to do a couple considerations from that, but you shouldn't be creating. I kind of want to support creating multiple sugarcanes, but like I don't know. If is suboptimal, if self recreate swap chain, self window resized. Actually, no. If the window's resized, then what do we do? Wait, hold on. If the window's resized. Oh, okay, that's what we do. If self window resized or self recreate swap chain, viewport. What's the viewport used in? Begin rendering. Begin rendering takes in. Do we have a dynamic viewport? We're using a dynamic viewport. Cool. Cool. That's useful. Yep, that makes complete sense. And we should be doing that. So we should be storing the viewport. That's what you're saying. Do we have... Where are we creating it? Are we just creating... Viewport. Viewport. There we go. Okay. The renderer can store the viewport. But does this have to do with... No. No, I don't think so. Offset depth range. What's the depth range? That's not what I want. Depth range is 0 to 1. Subpass. Oh, no. No, that's not what we want. Cannot infer type? What do you mean? What kind of type annotations do you want? What? Oh. Right. Cool, that works, I think. So we've begun our render pass. Now we could end our render pass immediately. pass and info default. It's nothing. It's nothing. Why are you yellow? Why are you this? Okay. Begin render pass. And begin, or no, bind, no, set viewport? Or is that done with, no, that's part of the graphics pipeline, so we need to bind a graphics pipeline. Bind pipeline graphics, self renderer, graphics pipeline, clone, set viewport 0, self viewport into, like that. Or we need to clone it, right? That's not, that's, whoa. Let's cargo check. Oh, okay. Small vec, volcano pipeline graphics viewport, viewport 2 from volcano pipeline graphics viewport, viewport 1. Required for, right, required for this to implement from, we don't have that. Because excuse me. Probably could use small vec better. Set viewport. Draw. No, bind. Vertex buffers. 0. Vertex buffer. We'll do that later. Draw. Vertex count. Oh no, this is insane. Right. Unsafe. Command buffer draw. 3. Instance count 1. First vertex this. And then like that. That works. First, and then we, okay. Let vertex buffer self graphics allocate a buffer buffer from an iterator. Data is a common vertex. Common vertex, new, position is, we need to make a vertex. Let's do -1, -1, 0. Actually, no. No, bottom left. 1.0, 0.0, 1.0. 0.0, 0.0. Let's format this. Can't format it because it's buffer usage. Vertex buffer. Memory type filter host sequential write. Is that automatically done? It is not. That's okay. 0, 1, 1, 0, 0, and 1. Let's put a 1 here and a 1 here, because I can. Let's do it. Great. W formatting. So you begin the render pass, bind the graphics pipeline, set viewport, bind vertex buffers, draw, and then we end the render pass. We need to end any of that. Doesn't feel like we need to do anything else. Ends the render pass previously begun with begin rendering. That requires dynamic rendering. Don't want to do that. Frame buffer. I mean, it would be cool. It would be cool. Do I want to do that? No. Cargo run. I mean, we're not even calling it, so there's clear values. Clear values. Oh. Or is that done in here? Render pass begin info. Oh, okay. You know what? Let's look at the renderer and see what we're doing. Begin render pass. Oh, right. Okay. That's what I was thinking. Into clear color. Oh. Is that gonna work? Yeah, maybe. I think so. You know what? Let's do it. Wait. I didn't even wait. Hold on. Not yet. Not yet. Never mind. I didn't even check the whatever the hell it is. The thingy where like we're recreating it and stuff. Oh, I need to like bind descriptor sets and stuff? No. Do I? I don't think I do. Oh my god. I have descriptor sets set up. You know comments in GLSL, right? These are compiled ahead of time. Those will be perfectly fine. bunch of errors. I mean, it's good, because then now we know. Transform times model times vec4. You know what? Vec4, position 1. Cracked. We've completely removed the need. This is a basic shader now. This is an incredibly basic shader. It's just inputs, some set of intermediates, and then one output. Great. Sugarcane. Draw stuff. It's not actually gonna put stuff on the window because we're not actually doing shit. But if we get an error now, it'll be better than if we get it later. I love building. I love build systems. I mean, all we've done is created a command buffer and put stuff into it. We haven't actually built it or run it at all. Why is it taking so long to build Volcano? It's such a huge library. Swap chain image. No, this is not the swap chain image. It's the acquire future. So we block on the acquire future and then execute the command buffer. Oh. 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 Okay. Please. You gonna work? Please work. Clear value is clear value float, but render attachments requires a clear value of type depth. What is this? This is adding textures. That's not what we want. Clear values. Sum 1.0 F32 into. Oh! We can't have an array. We can't have an array. Array bad. So a non-array float is interpreted as depth, and a singular array with a float with yeah. I don't even know what I'm trying to say. That's right. Wait. 13. So I assume I'm actually gonna print line drawing. So what I think this is. This should print twice. Once for the first draw, and the second 3. I guess we have 2. So we have the acquire feature, and we're trying to acquire it, but we never actually did. Block on. So you have to wait on the acquire fence, I guess, barrier, I don't know what the term is. You have to wait on the future. Oh! Oh, wait. Boxed. Wait. Then. Wait, hold on. Acquire future, then execute. on the graphics queue our command buffer build then signal fence and flush block on. Does that work? Does this work? A resource is not yet ready. You know what? Hold on. We could just wait. Still needs to join with this feature for present to work. Wait. Oh! Hold up. I don't remember what I did. Set texture, and I don't feel like just figuring it out again. A lot of it's just going to be I don't feel like figuring it out again, so I'm not going to, and I'm instead just going to look at what I did before, see like what I did, and see why I did it. So we sync join, take, then execute, swap chain. Oh! Then swap chain present. Prior feature, then execute the command buffer, then swap chain present, self graphics queue.clone, swap chain. What does this have? Oh, just the swap chain. Okay. That's why we need the image index. Wait. Oh wait. Swap chain image swap chain image index. Swap chain clone. Image index default. Does it do the exact same thing that I just did? Oh. Weird. What does default do? Clone debug. Where's default? Go to implementations. What? I didn't know that. There can't be default. Never mind. Swap chain image index. So we present graphics queue, swap chain image index. That looks good. Block on or wait. What's the difference? This is Polster. Oh my god, we have the thing. We did it. So we have a window now, and it's doing stuff. We can't close it. We do in fact have a thing. Hello. Oh, now what? So why isn't it actually drawing? That's my question. Is there something that I'm not doing correctly? Cause it... Oh, you know what? It's probably backface calling. That's probably it. It seems to be working. We should do like automatic like event processing. Like we should be doing that. And we're going to be doing that soon. Yay! Triangle. Hooray. Beautiful. Beautiful, amazing. So I can't actually close the window. Match event. Window event. Wow, okay, there's a lot of stuff that we can do. Close. Self close. Wait, hold on. Self GLFW window. Isn't there like a self window? Oh wait. Should close. Oh. Okay. Does it? Should close. Oh. Okay. I'm listening to it on my... That's it? On the preview. Oh. Oh, it's probably gonna it's probably gonna recurse. I'm listening to it on my... That's it? On the preview. It seems okay? Oh, it stopped, okay. Size, position. Ooh, size. Wait. Hold on. What happens? What happens when we resize the window right now? It's not going to recreate the swap chain. What happens? Huh? Wait, does it? Why does it work? Oh my god. Wait. Hold on a second. Wait, I think I see what's going on. Let's make it really tiny window. Like 160 by 90. Let's make a really tiny window, because I think like KDE or something might be. It's like low res. Wait, that's so cool. Wait, that's actually amazing. That's hilarious. That's not how I'm going to be implementing integer scaling, but like that's hilarious that that's a thing. Oh. Make the window 16 by 9. Let's try it. It's probably gonna like be... Oh! It's so dinky! Wild sugar cane. Window. Oh wait, should close. Or no, while not. Sugarcane window await should close. Do I make a... No. DFW poll events. We're doing stuff like manually right now, which is okay. We're gonna abstract this to hell and back because we can. Draw stuff. So this, we're gonna create a command buffer. All of so from here, we're going to okay. I need to like plan this stuff out. We can actually just take this from my old project, the swap train recreation logic. This I feel like I can do this. Is this? Oh. Self window. Lock. Oh, that's an issue. Wait, hold on. Window lock on dot get size. Map I32 cast inside. Yeah, that's right. GLFW returns I32s for window size for some reason. Graphics allocate image. Well, I guess because it's from GLFW is C++, or no, not C++, C. And there is a lot of issues with defaultness, which is why I like fixed size types. I like I8, I16, I32, I64, those kinds of types instead of char, short, int, and long, because the difference between U64 and I32 is much shorter. Like they're much more even types, or evenly named, than int and unsigned long int. That's a tangent, but I like I32, and I think that this is a result of C. Well, it has int32, but it also has int, and I think this is a result of that. Anyways, let's do actual things. I love uint64t. View? What? Oh, I had I had an extension thing that. Oh, I'm not gonna do that. I'm just gonna do this because the def buffer is an image. It's not an image view. So now it should. Now it shouldn't do like that low resolution dinky stuff. Unfortunate, but recreate swap chain window resized. Ooh, okay. We're going to do this. Size. I'm gonna match reference to event so that we can return some event, else return none. That, and then self window size equals true. Does this give me ints? Yes, it does. Okay. Right. You know what? Store true, ordering. Why do we have ordering imported? What's this used in? Right, I compared physical devices. Atomic. We're just gonna do standard sync atomic atomic ordering relaxed. Window resize is going to turn into an atomic boolean because I love atomics. So now I can false into load atomic ordering relaxed. Let's copy this. Load this. If window resized, store false relaxed ordering. Okay. That looks good. So now when we resize the window, it flags it so that the next time you draw, it will recreate the swap chain, recreate the images. Swap chain. Yes. Okay. So now if we create a tiny window, I mean it should just like say that like, wait. Huh? That's not what I want. Why is it doing that? I'm trying to draw the triangle, but like at like full resolution. The swap chain seems to be the swap chain seems to be completely stuck at the resolution that you give it. Is it? Why is it doing this? Image allocate, recreate, image extend, new dimensions. What? I don't get it. Hold on. We're going to creating swap chain. Yeah, I don't want to touch front end. I enjoy this more than I do front end. I've tried front end. It was weird. Like, this is esoteric, but all the operations are tiny and like map to hardware. But like front end is a whole different beast that I don't want to interact with at all. I see videos on like front end things and I'm just like, cool, I don't understand any of this. JavaScript is ugh. I don't like JavaScript. It's useful for web. That's all it's useful for. I'm going to be completely honest. Or embedded scripting. I've done stuff in industry and it was good. But like, people write entire back-end programs with it. People write so many things with JavaScript, and it's like, why would you do that? Why would you do that to yourself? Like, even Java is a decent language for doing back-end things. Java is like one of the languages to do back-end in. C# is I like C# better than Java. like either of those languages would be either of those languages are miles better than JavaScript because they're like they have actual types. Please just give me frame buffer. Yeah. Software rendering is fun. Do I wanna? I don't know if I want to have the option for software rendering. That would be cool though. I could actually, because you acquire a wait. Yes, you acquire a swap chain image, and you have you have the image. So like you can do whatever kind of you can if you create the swap chain images as transfer destinations, you can copy a buffer into it. So you can have like a side buffer that you just treat as pixels, and then I could fully support software rendering. That is a completely valid option I can do. That would be cool. It wouldn't be fast. It would be better, but does this deal do that? I thought it used like SDL has a lot of ways of rendering. There's like you can do like there's like surface to surface splitting, which is like I see what you mean. Yeah, I think there are quite a few operations in SDL that do stuff on the CPU. I don't know how many are GPU accelerated. Like they could use like a compute shader, like transforming a surface could be done on the GPU. But I've been kind of getting I want to get into SDL3 because it has a Vulkan like GPU API, and it will be probably better to use than like raw Vulkan because it would probably work on more things. WGPU would work probably on even more because it has like WASM. I don't even know if SDL has like WASM support, but yeah. To new dimension 0, new dimensions 1. Cargo run. Let's see if this works. It doesn't. Why? Am I storing correctly? I am. Print line. Why isn't it doing the thingies? Why isn't it? Why? Why? Is it like this? Can I do this? Am I not getting any GLFW events? Well, I'm getting the... Huh? Whoa. Why is this happening? What the huh? the most confusing issues have come. The most confusing issues that I've done with rendering have come with just setting up the window. Or the most difficulties I've had is with the window. You need to pass control flow over to the event loop. I don't want to do that. And GLFW, it's weird to interact with it when it's a C library. I prefer GLFW because I don't have to pass control flow over, but setting stuff up can be slightly harder. Events. Why isn't that working? GLFW, no events. No events received after preparing. Huh. See if we made GLFW visible. That's not what I'm doing. Swap buffers fails with no window. That's make context current swap buffers not what I'm doing because I'm Vulkan. What do I do? I'm very confused on what I'm supposed to do. Init no callbacks. Huh? What? This is weird. This is a macro. Args GLFW convert args. Okay, that's weird. Init. What does this do? Callback? Oh, it's just error callbacks? Excuse me. Init no callbacks. Window. Hold on. What? Thread safe GLFW? That's a thing? I didn't know that. Set frame buffer size callback. Does this... Is that... Oh wait. Wait, I'm getting the thingy! I'm getting the thingy! Oh my god. The thingy! This is gonna... This feels silly to do, but we're gonna do an arc-atomic bool. Because we need to set the frame buffer size callback, and it needs to be able to reference let window resized equals arc new atomic or no, false into. You know what? No. Atomic bool new false. So arc new atomic bool new. Let callback resize callback flag. Yeah, putting pixels on screen is hard. I guess it's like putting, I don't know. putting, I don't know. Resize callback flag dot, yeah, there's no set, store true. That's not what I want. Tonic ordering relaxed pudding. Ooh, wrong thing. There we go. False, false into. Wait, no, window resized. So this should work. I have a feeling this should work. Because like we're getting the callback and we're setting it. So like, oh, it's awful performance. But it works. Oh, this performs awfully. I'm pretty sure I'm going to have to... is there like VSync I can do? I wonder... Hold on. Hold on. Wait, no, I can just track performance like this. Let start equals instant. Oh, that's wobbly windows. I can make Windows do that. I love Plasma. It's working hard. It's trying to re-index stuff. Instant now. So instant now mouse start. So this should give us a duration, and we can see how fast we're rendering. It feels like we're rendering. I don't know how fast we're actually rendering, but let's check it. Oh, that's actually like not. Those like. Huh. Why is resizing doing that? That's weird. Hmm. I want to do something different right now. What do I do? So there's a few things that I need. I don't know. You know what I could? No, I don't want to do that. I don't want to do a communication. So this is just for general use. Actually, this is gonna be like, if I can make this good, then I could just use it for whatever I want. But what I want to use it for is the Minecraft communications, like to communicate with the computer in Minecraft. I just need something to make a UI in. I could use eGUI. I could use eGUI. Let's open a new so for now, and actually I think sugarcane might just become its own thing. For now, actually, hold on. IMGUI, it's nice. I think I would prefer it, but it's what Furnace uses. IMGUI is a great library, but eGUI's it's easier to use in Rust. IMGUI is easier to use in C++. And I've tried using C++ for this project, but there's just a couple things that make Rust like much better. Like the fact that I can just tack on a derive and just implement an entire trait. Like these can be serialized into binary, and then the other end can parse it. So like eGUI is an IMGUI library, like an immediate mode GUI library, like IMGUI is. Let's go with this, and cargo eGUI. I would use IMGUI, but it's kind of difficult. Oh, I thought that said dubstep. So, let's do some multi-threading. Honestly, let's do some multi-threading. Oh, it's lagging. It's lagging hard. Did it? Okay, it's... Wow. Wow. Okay, flashbang. Yeah. Minecraft. Wow, is still at like. Oh. Okay. Is it like, is it, oh, wow, my CPU's pinned to 100%. Oh my god, it's just. Oh my god. Can it actually, like, be performant at all, please? Please. Please, 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 please. This is not good. I can't, it's like still in the title screen for me. Oh, okay. Oh, I think it's speeding up. If this doesn't work, this is not gonna work. Is my CPU even like... Okay. Okay. Oh, why is it so low? Why is it such low quality? What's up with my... Okay, now my GPU is going crazy. Okay, we are streaming at... Okay. Let's... How well does this work?